Hello. This will be a demonstration of Proposition 24 from Book 10 of Euclid's Elements, which says that the rectangle contained by medial straight lines commensurable with one another is a medial rectangle. We're given two medial straight lines, AB and BC, which are commensurable with one another and which contain the rectangle AC. And what we want to prove is that the rectangle AC, which is contained by these medial straight lines commensurable with one another, is a medial rectangle. That is to say, the area of this rectangle is equal to some square whose side is a mean proportional to two rational straight lines commensurable in square only. Or that, more simply, the side of this rectangle we want to prove is a medial straight line. We will begin by describing the square AD on AB. We can accomplish this, of course, according to Proposition 146. Now, because AB is a medial straight line, we know that the square on a medial straight line is itself medial by definition of the medial straight line in Proposition 1021. So that because AB is a medial straight line, the square on it, namely AD, is medial. Now, AB was given as commensurable with BC. Furthermore, AB is equal to DB because they're both sides of the same square. So the definition of a square, definition 122, tells us that AB and DB are equal. So that because AB is commensurable with BC, DB, which is its equal, must also be commensurable with the same BC. But DB is to BC as the square AD is to the rectangle AC. We know this by Proposition 6.1. This square and this rectangle exist under the same height. They are in the same parallels, so that by Proposition 6.1, they are to each other as their bases, so that the square AD is to the rectangle AC as the base DB is to the base BC. But DB in step 3 was shown to be commensurable with BC. So by Proposition 10.11, that commensurability is going to transfer across the proportion, so that the square AD is commensurable with the rectangle AC. But in our second step, the square AD was shown to be medial. And we know by the porism of the previous proposition, the porism of Proposition 1023, that any area commensurable with a medial area is itself medial. So that because the rectangle AC is commensurable with a medial square AD, the rectangle AC is itself medial, which is what we set out to prove. So we're done with the proposition, therefore, etc., QED. This is another step in Euclid's project of rationalizing the medial straight lines, giving an account of their origin and their properties. And this is the sort of property that we were interested in rational straight lines. In Proposition 1019, which is the corresponding proposition to this one, we wanted to know what kind of area was contained by rational straight lines commensurable in length. And we found it to itself be a rational area. And by a nearly identical demonstration, when two medial straight lines are commensurable with each other in length, the rectangle that they contain is also medial, just as the squares on them must be. And so this further legitimizes the medial straight line as a class or a kind of rational straight line. Instead of putting it on the outside of rationality by calling it irrational, Euclid has instead taken the irrational straight lines, classified a kind of them, and continues to demonstrate, as he had in the previous propositions, and will continue to do in future propositions, that class of medial straight lines, as he calls them, is a legitimate class of rational straight lines with many of the same properties as a class as the class of rational straight lines did. That's all I've got to say about Proposition 1024, so I will end the video here and move on to Proposition 1025.